Hello friends, so today we are going to discuss again some tree problems, and these are like basic problems which you should know, and once you know these algorithms you will be able to solve other problems. And these are again recursion based problems. So first problem we'll be seeing it will be like finding maximum depth of binary tree. It seems simple, and I have chosen a simple question because I want to show you what you need to know, and so that you can use that knowledge for other problems. So here in this problem we'll find out the maximum depth of binary tree, and second problem we will do where we need to find out the diameter of a binary tree. Before moving to solving these problems, let me tell you what I wanted to show you, and what is the approach which we are going to take. So before moving to solving first problem, let's understand few concepts about recursion. Okay, so consider this is an queue or line of people, and this is the front and this is the end of the queue, and this guy wants to know what is his or her position in the queue. And let's assume that queue is so long and he can't just count and know his position. So what he can do, he can ask this guy, hey, what is your position? Because he knows once he gets the answer from this guy, he can simply add 1 and that will be the answer, that will be the position of his. So but same happens to this guy. He doesn't know his position, so he will ask this guy who is in front of him, hey man, what is your position? Same way it will ask this guy, and at the end this guy will see, okay, there is nobody, so my position is 1, so it will return this guy as 1, and this guy will know, okay, so if its previous position is 1, so his position will be 2, so he will return 2. Same way he will return 3, and he will return 4 here, and the final answer will be like, he will be knowing, so there are 4 guys in front of me, so his position will be 5th position. So you can think of this guy like a function, and it is calling another function, so it is asking this function, hey, what is your position? Same way, and this link is not broken, so it will be until this replies back to this guy, and at the same time this guy is again calling this function is calling this function, this calling is this function, and at the end we have the base condition. If there are no more guys, so base condition is what? If so, last condition to check. So this guy will see, okay, if there are no guys in front of me, just return 1, so it will return 1, then it will return to this, and this will be broken, so this function call has ended now. Same way this guy will return to this function, and once it is written, this function call will be ended, and at the end we will have the final answer to this person, and he will know his position. Okay, so let's solve this problem first. So maximum depth of a binary tree, maximum depth is the number of nodes along the longest path. So for example, from a root node, number of nodes from this node to this node is 2, so this one's 2, so this is maximum depth of 2, and from here it's 1 2 3 here, and again 1 2 3, so maximum will be 3. You can either take this path or this path, and you have to read the question carefully. It is saying number of nodes, it's so basically 1 2 3 and including the node, root node. So this type of problems are like, they are little bit of easier, because what we need to do, we just need to do a recursive call, and each intermediary node will just return its value to its parent node, and when we are back at the root node, we can just calculate the final answer, and we have to calculate the same way at each level. Okay, so how we can solve this problem? So this node will call recursively its both children, and it will ask, what is the maximum node from you? So 3 will ask 20, what is the maximum depth from your level? And it will ask from 9, what is the maximum depth from your level? And same way 20 will ask from 15, what is the maximum depth at your level and maximum depth from your level? And finally, once they return back the value, so intermediary node, they just have to do the maximum, take the maximum of left or right value, add 1 and pass it back to its parent, and at the final we will have the result. Okay, so whenever doing a tree problem or any recursive problem, first you need to write a base condition. And what is the base condition for most of the tree based problem? If root equals null, we have to return some value. So here we will just return 0, and then what we are doing, so for example this node will ask its left child and right child same question, what is the maximum depth at your level. So left depth, and it's like recursive call because we are going to do the same thing from left node and right node. So root dot left, and same way we'll ask the right child max depth root dot right, and the answer is simple, we just need to return 1, so its value plus max of left child's result or right child's result. That's it. So if I run this code, I got the right answer, I can submit it. Okay, so what is the runtime of this problem? So we see like this will call its left and right child, and again they will call left and right, so it will be order of n, so runtime is order of n. And what is the space complexity? So as such we are only using two variable, left depth and right depth, so they are order of 1, but we are using recursive call, so each recursion also adds a value to a stack, and that is also considered as a part of space complexity. So here what maximum we can have, so for example if this tree only has right child at all the levels, so we will be doing order of n recursions, so space complexity is order of n. Okay, so let's move back to the second problem, and here the problem is little bit different because here the answer can come through either from root node or from any other node. So only difference between these two problem is like here there are two or intermediary node can also have the final result, so we need to take that point in consideration. So at each level we have to solve two things, one, find the local answer and pass back to the parent so that it can calculate its max diameter or max diameter. At the same time the intermediary node has to calculate its diameter and check with the global maximum diameter whether its value is the current maximum or not. If yes, it will update that value at the same time. So it has two functions now at the intermediary level. It has to first calculate a local value which it can return to its parent. Second, it has to contribute in a global answer, and it has to check is it generating a value which is the final answer. So there are two questions to this intermediary node, final answer and local answer, and you can easily find out the difference between these two type of problems. So if you are always going to get the final answer from the root level, so it means that the intermediary nodes are no longer calculating or are part of calculating final value. They just have to calculate their own value, we will call it as a local result, and pass it back to parent level, and when that parent is root, it will generate the final value and it will return back to the calling function. But in second type of problem, even the intermediary nodes can have the final value even though they have to calculate the local values and pass it back to root node or parent node, but it also has to see whether it is contributing to the final result value. Okay, so this example what we are seeing here, the answer seems to be pretty simple because it's a very simple example. So the depth from root node is maximum, so for example left depth is 1 and 2 here, and right depth is 1, so total diameter is 3, and for others, for 2 it's a 1 and 1 2. So but let me draw a good example where we will see how come an intermediate node can have a final result value. I have drawn a very bad tree structure, but it gives you the idea. So for example, in this example, if I see this node and the diameter from this node, it will be like 1 2 3 4 5 6 7 8 9, so it is 9. And if we check the value for root node, it will be 1 2 3 4 5 6 7, and this one 8. And similarly, if I check this side, so 1 2 3 4 5 6 and 7, so root node has a 7 or 8, and this node has here 9. So this is the final answer. So here we see like intermediary node can also have the final answer, but to calculate the diameter at other node, it also had to return the local values or local answer to its parent node, so that it can return to its parent node, so that these values could be calculated or can be calculated at each level. But at the same time, we have to check at each level whether that is the final answer. Okay, so just remember, in the previous type of problem, you always have the final answer when your complete program is done and you are again back to root level. But in this type of problem, again your complete program will be done and you will be back at the root level, but at the same time you are creating local values to pass it to parent values, but at the same time you also have to see whether are you contributing to the final result. Okay, let me directly go to the problem and let's see what different we are doing in these type of problems. Solve this problem. So here, as we already know, we are calculating a diameter of a binary tree. And what is the diameter of a binary tree? It is the longest, is the length of the longest path between any two nodes in a tree. So here, if you see, it's a 1, 2 and 3, right? And here 1, 2. So for this one, the final answer goes from root, the answer is 3. Okay. So the way we do all tree problems, first we'll write a base condition and we'll say if root equals null, you return 0. And then two things. First, we need to find local answer, then calculate or check final answer, calculate or update final answer, and third one, return local result to parent so that they can also calculate the values. Let's write a different function because that function will have several lines, so it's always better to modularize your code and write a different function. And it's okay to write a root this line in the main function. If root equals null, you no need to calculate any value, you can return 0. And then you can call a helper function and you can pass the root. That's it, right? Okay, no, I don't have any other values. And we need to return the final answer, so return max diameter, right? And what we can do in these type of problem, for a final value you can use a global variable. There can be other methods also, but you can, for these type of problems, you can use this approach also. So for a final result, because you know you have to calculate final result at each level, so so it means that you should have an access to a variable at each node level, right? So it should not be a function level variable, because then its scope will be a function or method. It should be a global scope variable which will hold final answer. So I will use a max diameter, and for a max value you normally use, or almost you use min value, so that it will be easier to use math.max, and this default value will always be overridden by some value. Okay, and I am calling helper root and I am returning max diameter here, and you can ask me why I am not updating anything here, but what I am telling you that in the helper function anyway we'll update max diameter, and when the helper function is done we can simply return the final value of max diameter. Okay, so let me quickly write helper function. So int helper, and what is passed to it, it's a tree node root, and again we can write a base condition here, which is basically if root equals null, you return 0. And then we have to do these three things. First, find local answer, then calculate or update final answer, and then return local result to parent so that it can do its function. Again, the problem is like I need to find the int left depth, and same time I need to find int right depth, right? Okay, and I can call the same function, helper function, and I can pass the left here, and here also I can call the same helper function, and I can pass right child over here. Okay, so how do I calculate or update the final answer? So first I need to calculate the local result, then I have to compare it with the final result, and then I need to return it. Okay, so local answer will be like the sum of left depth plus right depth, because here what the question is asking us, longest path between any two nodes. So if, for example, if I am checking at this node, so distance between 4 and 5 is going through 2 and it is 2, right? So at this level I can simply sum up left and right depth and I can say the maximum diameter is sum of left and right depth. So local result will be, so I will say local diameter will be left depth plus right depth. Okay, and what will be the, and how we will update the final answer? So it's simple. So max diameter is equal to math dot max left depth or right depth. Oh, sorry, math dot max local diameter comma max diameter. So whichever is maximum, you just update its value. And what it should return to its parent, it should return, so for example, if you are at this node, it should return the maximum of left and right, so that it can calculate either of these, it can use either of this child's right side maximum or left side maximum, so it does not have to bother about that thing. So this node will calculate what is the maximum side from it, so either left or right, and plus add 1. So return 1 plus math dot max left depth comma right depth. Okay, so we did 2-3 things here. So we first calculated the local answers and we updated the local value, and then we updated the final value, and then again we returned the value to the calling or parent function. Let's quickly run it. Okay, so we see this problem is solved. So yeah, why I did these two problems at the same time, because I wanted to show you that you have to understand the problem first. So if there is an answer always going through root or any one node, then you no need to worry about the local result and should not compare that with the final result. You can simply return the local result to its parent, and then you are free, and the final value will be calculated once all the function calls are done. But in these type of problems where final result can come from either root node or any other node, you have to first calculate the local result and then update the final result and then return the local result back to the parent so that it can do the same thing. Okay, let's understand what is the space complexity here first. So as such, we are only using left depth, right depth, local diameter and max diameter, and these are again 4 variable order of 1. And because we are doing a recursion call here, so stack will have some space. And again, for these type of problems, in case if you have just a tree with one child at the at each level, so it will be order of n, because you have to put in a stack all the function calls, and again it will be the number of nodes. So order of n is the space complexity. And what is runtime complexity or time complexity? Anyway, we are visiting each node, so it's order of n. And thanks again for watching. Please like and subscribe the channel. Thank you. Bye.